Welcome back, everyone. We are now ready to resume the program. Ladies and gentlemen, please join me in welcoming Dr. Stephen Ibaraki, author and global chairman of REDDS Capital. Dr. Ibaraki will talk about harnessing powerful emerging innovation and AI applications in an industry and technology. Welcome.
So it's a pleasure to be here, and I want to welcome everybody. Now I'm going to talk about harnessing the 10th machine age, amazing technologies for the brighter and sustainable future. And we're at a point of a double exponential rate of innovation where we have more innovation occurring now in the next 5 years than the past 2 million years. It will be totally disruptive to the entire planet and all Earth ecosystems. And this is because for the first time in the history, we have this convergence happening of supercomputing, quantum computing, chip technologies, biomedical innovation, and interwoven into all of this is AI and machine learning. So do you have a fear of missing out or fear and uncertainty and doubt with this 10th machine age? Now, throughout my keynote, I'm going to play videos, and what I did is I reached out to the world's top experts for my keynote today. And you're going to hear words from the top experts by me playing some of my conversations with them, but I recommend you go to the underlying 1 to 3 hours of extended conversations. So first of all, I reached out to the head of the world's largest UN agency and the world's largest innovation accelerator.
Thank you, Stephen. At the World Food Pro Innovation Accelerator, we are pioneering groundbreaking innovations that can help us end global hunger. Last year, our portfolio of innovations already impacted a total of 61 million people, and they have raised a total of $295 million of grant funding. Some examples: Hunger Map Live is a tool we've developed as a map that uses AI for even forecasting food security into the future. With the German Aerospace Center, we're developing a semi-autonomous vehicle that can be used in hard-to-reach areas where it's too risky for people to go into. And then a startup, Bomitra, is using AI, soil samples, and also satellite imagery so that smaller farmers use regenerative agriculture but also benefit of carbon credits. Now, together we can achieve a lot more, and we can end global hunger with innovation and technology.
So they're an open platform where all of you can partner with them, and they just announced their Kofi Annan Award winners, which are additional startups. Now, I'm a founder of AI for Good, which is owned and operated and hosted by the ITU. So we have our Innovation Factory, we have our Impact Initiative, they have the AI Skills Coalition. They also have the Partners to connect all 8 billion on the planet in GIGA, which is to connect all schools and many, many more. Now, it's an open platform, so you as an individual, or as a corporation, or a community, a school, you can all participate with ITU in all of these different programs, and they have the largest resource repository to help you in the applications of all these technologies.
The AI for Good Global Summit aims to bring together industry leaders to try and harness AI to further the UN's development goals in areas like health, climate, and sustainability.
How do we govern technologies if we don't yet know their full potential?
The main purpose of this summit is to explore how the AI solutions can help sustainable development.
AI will come to influence almost every aspect of our societies and economies.
AI 治理框架
AI for good.
I would say the most pressing topic at the summit is going to be how do you handle deepfakes, misinformation.
成为 AI for good.
Cumbre Mundial All for Good.
The good news is that the future of undetectable deepfakes can be avoided through the development and implementation of robust detection technologies and international standards.
General purpose technology and provide amazing power to change the world.
And that's what makes me so excited about what AI for Good is all about.
1/3 of humanity remains completely offline, excluded from the AI revolution.
Artificial intelligence is changing our world and our lives, and it can turbocharge sustainable development.
We are the AI generation, and this is our moment, and it's our responsibility to write the next chapter in the great story of humanity and technology.
So keep in mind the next year is a year of quantum. Now, what questions should we be asking ourselves about the 10th machine age when you have this convergence of supercomputing, quantum computing, chip technologies, biomedical innovation, AI, machine learning? I've listed some of them here, but just to illustrate the power of AI, I created an AI avatar that's going to say these items in French. So see if you can follow along the French with the items on the slide.
Donc, nous avons quelques questions à examiner.
If you can elevate it, please.
3,5% peuvent initier un changement systémique. Il y a 500 trillions de richesses mondiales. Il y aura plus de transformations numériques dans les 5 prochaines années que dans les 2 derniers millions d'années. En fait, plus de 90% d'adoption mondiale de copilotes IA en un an. Plus de 80 nations élisent des dirigeants cette année. Le réchauffement climatique dépasse 1,5 degré Celsius depuis 24 mois et le glacier de l'apocalypse va s'effondrer. Comment assurer l'amélioration de la curiosité? L'apprentissage prospectif des marginaux. La pensée critique, la capacité d'empathie, l'agence individuelle, la responsabilité et une adaptabilité continue et ciblée.
And how about these other questions? How about the global education system, where by 2027, 70% of the world's workforce needs reskilling? How about decentralized finance, which will hit $100 billion in 2025? How do we harness the power of indigenous citizens' knowledge systems, who now manage over 25% of the land surface of the world and are custodians of 80% of the planet's biodiversity? How about advances in biotech, where genetically modified crops are exceeding $50 billion by 2027? How about cybersecurity threats, which are exceeding $12 trillion by 2026 in cost, and they're already over 50 billion security events per day? What about declining biodiversity, where the world wildlife populations have declined by 70% since 1970? To illustrate further the power of AI, I put together a series of demo videos, starting with this one where I captured a photo and then animated with Kling AI, which just dropped their latest model. So here we go. And everything you see was created using AI.
Have you ever had, maybe you're in that place right now where you want to turn your life around?
We introduce VASA. Our model is capable of not only producing lip movements that are exquisitely synchronized with the audio, but also capturing a large spectrum of facial nuances and natural head motions that contribute to the perception of authenticity and liveliness.
Global leaders unite, discover Armenia's light. World Congress in sight, supercomputing flights.
Hey everyone, and welcome to, well, your own personal deep dive. Ever heard of Giga?
I think you're about to become very familiar with them, actually.
Oh, this is good stuff. Really fascinating. Okay, so imagine a world where every single school, every single one, no matter how remote, has internet.
Ambitious, right?
Totally. But that's Giga's mission.
So the future is here, including Unitree launching their robots for home for under 16,000. Figure 1 has now become Figure 2 and now Figure 3 for next year. To me, it has elements of AGI, and BMW is already using them in their plants. You see OpenAI release of the O1 model, which reasons like an AI, like a PhD expert. So we're in a period of transition where we have classical human beings like all of us here. Some of us are augmented. For example, I have hearing aids with AI. You can actually now get a fully articulating robotic arm as an attachment, and humans can be genetically edited. So those are hybrids. And you're already going to have autonomous next year with robots, and taxis are already out there. This was just released, the AI Scientist. It's open source, it's free. It can automate scientific discovery. It can generate novel ideas, design experiments, conduct the experiments, analyze the results. It can write the scientific paper and evaluate it for quality. It's already being reused to write papers, and the framework could be adapted to things like physics and biology. Chip technology is going and accelerating on unbelievable rates. For example, computational RAM, 1,000 times less energy. Carbon nanotube chips, 3 times better in performance, 10 times less energy. Photonic chips can be up to 1,000 times less energy, potentially more capable. To illustrate, I reached out to John Hennessy, because he's the chairman of the board of Alphabet, which owns Google, which makes their own chips. In fact, they even use AI to design their own chips. John has also, with David Patterson, created a new chip architecture 40 years ago, which is the underpinning of all chips used today. He's also the president emeritus of Stanford. He's a well-known company founder and investor. Here's John, and I've got 3 hours of additional content. You got to look at the underlying content.
Given the slowdown in Moore's law, issues with energy efficiency, and the answer to that is sort of multi-chip, 3D, stacked kinds of things, probably using integrated circuit technology to allow extremely high density interconnects to be done. The real challenge after that is there a technology to replace silicon? Philips worked on carbon nanotubes. There are a couple other thoughts out there. I mean, you don't build. A car has more than 1,000 chips in it now. So you basically, everything that's modern is covered with silicon.
Philip is the chief scientist of Taiwan Semiconductor, and he's already working on this chip you can put into a cell.
Then put a chip inside a cell and communicate with it. And the next thing we want to do is to affect the behavior of the cell. And for example, having a means to maybe release a drug or something like that.
Not that long ago, you had 1 billion transistors in a cell, in a chip. You have the NVIDIA module already being produced by Taiwan Semiconductor, 208 billion transistors. We're going to hit over 1 trillion under a decade. Apple just released their iPhone 16, which has an A18 Bionic chip. I estimate 27 billion transistors, but it could do 35 trillion operations per second. That's a supercomputer in your hand. Biomedical innovation is accelerating at rapid rates. Aging will be solved. For example, Yamanaka won the Nobel Prize in 2012 for discovering 4 genes that you can insert into a cell and rejuvenate it to the point of being even a stem cell. There's all of this amazing work occurring at Terasaki Institute. Now, David Sinclair at Harvard has taken 3 of those Yamanaka genes. He can actually put it into mice and rejuvenate mice. Ali is the founder, CEO within Terasaki Institute. I'm on the leadership board. We're already working on the bioprinting of organs.
It's been shown that tear from the eyes can actually be able to have biomarkers that are associated with diseases like diabetes or dry eye disease, or even things related to mental health. So this ability to detect some of these biomarkers from the tear is something that we've been very excited about, but there's been very limited approaches to test this. Obviously, you don't want to have someone have to give you a tear sample to do it. So we've been interested in developing technologies that enables this in a very seamless, non-invasive manner. And one of the technologies that some of our scientists have developed is a contact lens which is very comfortable, very much similar to existing commercial contact lenses, with the difference that it has the ability to detect these specific biomarkers in a real-time manner. So Whole Meat, for folks who may not know, is a cultivated meat company. It's basically growing cells from livestock like cows in a bioreactor, in a so-called cultivator, very similar to a beer brewing process, to make large amounts of these cells to basically make meat without slaughter of animals. So we started that company about almost 3 years ago, and it's now just about to finish its next financing for Series B at this point.
Ali's ranked in the top 10 in the world, and they just got a grant from the US National Institute of Health of $2.3 million to continue their work on organs on a chip. Now, this is my view of technology adoption in the next few years. Financial services, 160 trillion, healthcare, 18 trillion, but see in the 90 percentiles for AI machine learning, and even in the 50s for quantum computing and robots. And if you look at the right side, that's across all industries. The numbers are very large. Supercomputers are now exascale. That's a billion operations per second. Today, Japan announced they're going to have a zetascale. That's a billion operations per second by 2030. You can model the climate. You can model the entire planet, the human brain. You can work on drug discovery. New kinds of batteries. There's no limit. Quantum computing is now functional in many respects. There's already people working on condensed matter physics, which can apply to semiconductors, to N quantum Monte Carlo, which can be used for financial services, logistics, and physics. Now, the human brain has 100 billion neurons, and I now estimate over 250 trillion connections. Well, a really famous scientist by the name of Geoffrey Hinton, who won the Turing Award, which is the Nobel Prize in computing science, and for his work on AI that underwrites everything you see today, earlier at Oxford, is hinting that maybe these things learn better than human beings. And you just saw that announcement from DeepMind with the AlphaFold 3 being released. They're showing how amino acids can fold into these protein structures, 3D structures, to over 200 million of them, and they can show the interaction between proteins and RNA, DNA, and ligands. This has applications in the environment, renewable energy, green chemistry, evolutionary history, healthcare. If you went 5 years ago, the known universe wasn't 200 million, it was only 200,000 proteins, and it took 70 years to get there. If you were to apply that technology to get to over 200 million, it would cost $100 trillion and take 100,000 years. This is Krista Savor, top expert in quantum computing. I'm not going to play a video. I recommend you go to the underlying our conversation. But she talks about how a fundamental unit of a quantum computer is something called a quantum bit or qubit. And it breaks down, and you can't use it because it's not stable enough. And that's called level 1. Well, in April, they made a major breakthrough working with another company called Quantinium. So remember that name? Where they were able to reduce the errors by 800 times. And that means some stability and fidelity, which means you could start thinking commercial applications. So we're now at level 2, and level 3 is when you scale it, and you definitely will get commercial applications. She also talks about combining supercomputing, AI machine learning, quantum computing in a new Microsoft service available in the cloud called Azure Quantum Elements. All of you can use it. And they wanted to prove it works, so they said, what if we can come up with a new battery? So they sorted through 32 million novel battery materials in 80 hours. Before this, it would have taken over 40 years. They found a new material. They worked with the lab. They synthesized it. It works, and it uses 70% less lithium. They've also created a co-pilot, so a 7-year-old or a 10-year-old, for free, can start being guided into writing their own algorithms. Quantinium. This is Elias Kahn. He's the founder of this company called Quantinium. #1 in the world with a major breakthrough. In fact, they just announced another breakthrough where they did something called high-fidelity, fault-tolerance teleportation of virtual logical qubits. We won't get into that, but I'm going to play a little bit here, but there's underlying 3 hours I've done with him and his team where he talks about the applications. So here we go.
I would recommend that people start thinking about the impact of quantum computers together with large language model type generative AI systems and obviously high performance compute clusters in the context of computational biology. It's not about living forever, it's about living longer and living with dignity so that we're no longer tackling the symptoms of aging, but we've tackled the root cause. And so things like oncologies and various oncologies, as well as Alzheimer's and senility and diabetes and other sort of related illnesses that are immune deficiencies. These are now really within reach. I would encourage people to think about that. And of course, the economic value of that is that it's incomparable. Nothing comes close. Nothing comes close. So that's one. And then the other thing, so that's the thing to contemplate. And the question to ask, I think, would be, where should my organization now start thinking about the impact of quantum, either with my competitors or in my own processes? And I think it's now time to start doing that.
So they just released their roadmap, and they work on multiple generations at the same time. So the Helios, by the way, over a period of years is 1 trillion times more capable than their H2 version and 1 trillion times more capable than the H1 version. And if you look on the right side, that's the Apollo. That's their proof now of some elements, at least, of universal quantum computing. What that means is quantum computing actually working, solving real commercial problems that cannot be solved with any classical computer, and then magic is happening. So I told you that we are in the 10th machine age for the first time in the history of the planet. The confluence, the coming together of supercomputing, quantum computing, chip technologies, biomedical innovation, AI machine learning, coming together in an unprecedented way, which will fundamentally change every aspect of your life, your country, your society, your business in a way that you cannot imagine, and it's going to happen in 5 years. More transformation than the past 2 million years. So that ends my keynote. Thank you for allowing me to share some of my insights with you. I want to bring up, I've got a few minutes left, two amazing organizations, one called the ACM, we're the world's largest computed science organization. All sorts of resources available to help you implement these kinds of technologies. The other one I'm part of is the IEEE. We're the world's largest technology engineering organization. Again, all sorts of resources that can be utilized by all of you as an individual, as a company, an organization, a country, and more so. So again, thank you again. I enjoyed my time here. If you see me walking the floor, happy to answer questions. Now, I'm going to go off the stage. I'm going to go to another slide here. I actually created a AI avatar that, like an anthem for your Congress here.
Global leaders unite. Discover Armenia's light. World Congress in sight. Supercomputing flights. Quantum chips on the rise. AI in our eyes. Biomedical ties. New age to the skies. Double exponential time. 10th machine age prime. Investments in our climb. New innovations chime. Quantum chips on the rise. AI in our eyes. Biomedical ties. New age to the skies. Double exponential time. 10th machine age prime. Investments in our climb. New innovations chime. Tech waves crashing in, worlds